Hey everyone, and welcome to our next episode of The Cosmic Classroom. Today's episode was made especially for third graders in Miss Carole Zanardi's class at Stella Maris Academy. We've got a fun show planned for you today that covers constellations, the phases of the moon, and moons around other planets. But before we get started, we need to zoom in here on the Earth and land in front of your school. Let's go. So here we are in front of your school, Stella Maris Academy, Holy Rosary Campus. You can see your school here embedded within our special astronomy software that allows us to show you the daytime and nighttime sky as it actually appears at any time on any date. So to get started, let's go ahead and make the sun here set, which would be setting nearly behind us in the west. And as the sun sets, twilight will set in and you'll see all of the stars in the night sky come out. So as you know, the night sky can be divided into several constellations or patterns of stars. Let's see which ones are visible tonight above and around your school. A few hours after sunset, you'll see the constellation Ophiuchus directly above your school. Ophiuchus represents a man holding a snake. If you look towards the east, you'll see the constellation Aquila, the eagle. You can also see a smaller constellation with a really bright star called Lyra the Harp. That star's name is Vega, one of the brightest stars in the night sky. Down and to the left of Lyra, you'll see the constellation Cygnus the Swan. Cygnus is relatively easy to find in the night sky because of its distinctive cross shape. And if you look very carefully, you might notice that the neck of the swan points along a really faint band of light that stretches across the entire night sky. That's the faint glow of the Milky Way galaxy, the galaxy in which we live. It's made up of roughly 200 billion stars. The farther out into the countryside you go, the brighter it will appear. If you look a little bit below Cygnus the Swan, you'll see one of my favorite constellations, Delphinus the Dolphin. And then to its left is another small constellation, Lacerta the Lizard. If we turn around and look towards the west, you might see the constellation Leo the Lion setting in the western sky. And then up and towards the north, you'll see Cassiopeia, a famous queen. And then above that, the famous large constellation Draco the Dragon. Now, Miss Zanardi told me your class recently has been studying the moon and its phases, like the first quarter phase, the full phase, the third quarter phase, and the new moon phase. Unfortunately, if you go outside the next couple of nights, you're not going to find the moon anywhere in the night sky. That's because it's currently in a new moon phase. It rises and sets with the sun, and on top of that, you can't see any part of it lit up. So to understand why that phase looks the way it does, and to understand all of the phases, we've got to go to space. So about 250,000 miles from the Earth, you'll find Earth's only what's called natural satellite, the moon. It's a spherical, rocky object about 2,000 miles in diameter. That's roughly the same size as the United States, and it orbits the Earth once every 27.5 days. To understand better why we see the moon the way we do and the phases of the moon, I want you to understand and memorize three main facts. The first fact is that the moon doesn't really emit any of its own light, it only reflects light, kind of like a mirror. So any light you see from the moon must have originally come from the sun and then bounced off of the moon. Think of the moon like a basketball and the sun like a flashlight. If you shine a flashlight on a basketball, you will only ever be able to light up half of the basketball. But what you see on the basketball depends on where you're standing around it. And the same thing is true for the moon. If I am looking at the part of the basketball or moon that's not lit up, I see a dark side. And if I happen to be looking at the side of the moon that is lit up with the sun behind me, I see what looks like a full moon, the whole thing lit up. The second fact I want you to memorize is that the moon orbits around the Earth once every 27.5 days. It's always changing its position. So if we look at the position of the moon in the night sky at a certain time, let's say sunset, if I go out and look at the moon again the next night, and then the next night, and then the next night, the position of the moon will change night after night as it orbits around the Earth. The third fact I want you to memorize is that the moon rotates or spins, and it spins roughly once per orbit, meaning every 27.5 days the moon will spin once completely and have orbited the Earth once completely. And this has a strange effect. If an object spins as quickly as it orbits, it means the Earth will always see the same part of the moon facing it. In this example, you can see two objects, one that's spinning or rotating, the moon, and one that's not, labeled I don't rotate. So as time goes on here, you can see that the Earth will always look at the same side of the moon, the object that's rotating, but will always see different parts of the object that's not rotating. The main effect for us on Earth is that we always see the same face of the moon. And here's the weird thing. If one side of the moon is always facing the Earth, that means if we could stand on the moon and look back towards the Earth, we would always see the Earth up in the sky. It would never set below the horizon. So even though we can't see the other side of the moon, sometimes called the dark side, it does exist. So here's an example of that, and it's not always dark. Sometimes it's lit up with light from the sun, and sometimes it's not. Alright, it's now time to put all three facts together to understand why the phases of the moon look the way they do from the Earth. So we'll start with this simple diagram. You can see the Earth, the moon, and the moon's orbit labeled with a green line. The sun's here too, but it's so far below the bottom of this image that you can't see it. So make sure you remember at all times the sun is way down below. And you can tell that because notice the bottom half of the Earth and the bottom half of the moon are the two halves that are lit up. So that tells you light must have come from below. So as we animate this, you can see the moon orbiting around the Earth as you already know it does. And when the moon stops in this configuration, we see here on Earth what we call a new moon. Anyone on the Earth at this moment would have to look towards the bottom of this image to see the moon, and if you remember, the bottom of this image was also the direction you would look in to see the sun. What does that mean? That means the new moon and the sun would be together in the sky. Notice also that the Earth is looking towards the dark side of the moon, the part that's not lit up. That means if you looked in the sky at a new moon, well, the first thing is you could only see it during the daytime. It's next to the sun in the sky. And on top of that, if you could somehow get rid of all of the light from the sun and magnify the image of the view, you would still see the dark face of the moon. Why? You're not looking at the part of the moon that's lit up. So if we jump ahead 7 days or 1 week, the moon will continue in its orbit around the Earth. And if we stop in this configuration, we have what's called a first quarter moon. Imagine yourself on the Earth looking towards the moon in this case. You'd be looking towards the right side of this image, and you would see a little bit of the part of the moon that was lit up and a little bit of the part of the moon that was not lit up. So if we imagine this as we would see it in our night sky, notice here we can see half of the moon lit up from our perspective. This again is what we call a first quarter moon. As we jump ahead another 7 days as the moon continues to orbit around the Earth, we'll stop at a very special location, one at which the Earth is almost directly between the moon, near the top of this image, and the sun, which again is way below the bottom of this image. And this is what we call a full moon phase. Imagine yourself again on the Earth. In order for you to look at the moon, you'd have to look towards the top of this image, but remember the sun is down below at the bottom of the image. Therefore, the sun and the moon would be opposite one another in the night sky, and on top of that, you would be looking fully at the part of the moon that is lit up. So going back to our view of the night sky from your school, you would see a beautiful, fully lit up full moon rising above your school, right about when the sun sets behind you towards the west. If we plow ahead another 7 days, 1 more week, we'll approach what's called the third quarter moon phase. Just like the first quarter moon phase, the part of the moon that you're looking at is halfway lit up and halfway not lit up. So if we go back to an image of the night sky from your school, you would see the other half of the moon lit up compared to the first quarter moon phase. Now, very few of you have ever seen a third quarter moon phase. Why? The third quarter moon phase doesn't rise until midnight, when you're probably fast asleep in your bed. And last but not least, if we jump ahead another 7 days or 1 week, we go from a third quarter moon back to where we started, a new moon, when the moon is between the Earth and the sun. It took about 1 month for us to go through all 4 of those phases. So where do you think the word month comes from? What if I said it like moonth? That's right, in 1 year, the moon goes through roughly 12 of these cycles, so we easily can divide the year up into units based off of the moon's phase cycle, which we call months. Now we've spent almost the entire show talking about Earth's one moon, but did you know almost every other planet in the solar system has not just one moon, but dozens of its own moons? Why don't we check them out and go visit all of them real quick? Let's go. Our first stop is Mercury, which doesn't have any moons. Next up, the planet Venus. The second planet from the Sun also doesn't have any moons. Next is Earth. Of course, we have one moon, its orbit shown here, and we call it the Moon. Mars is interesting. Mars has 2 different moons called Phobos and Deimos, which mean fear and death. Jupiter has a whopping 79 moons. You can see their orbits labeled here in red. When it comes to moons, Saturn is king with 82 discovered moons. Uranus also has 27 of its own moons. They're named after characters in Shakespeare's plays. And last but not least for the planets is Neptune, which has 14 of its own moons. So as you can see, our solar system is full of exciting moons around most of the planets. That concludes today's show. We'd like to give one last shout out and thank you to Miss Carole Zanardi and all of her students. We hope you're doing well, and we hope you take time out of your nights to go stare up at the night sky. So with that, don't forget to keep looking up.